All right, guys. So earlier today we had a meeting that you may or may not have made it to. For today, that's okay, considering I messed up with my period. I think it's my period 4. You guys got the link late or the wrong link originally. I don't know how that happened, but I'll make sure it doesn't happen again. So at any rate, what we recapped was how to solve x-intercepts using the square root method, which are these 3 examples right here, okay, and the outcomes. So here in numbers 1a, b, and c, I guess that's supposed to be a, b, and c, but it's a, b, and b, but it's supposed to be c. In this first example, there was one real solution. The second one was there's no real solution, and the third one is when there's 2 solutions, okay? And we utilized the square root method to solve each. So if you need a pause, go ahead. Now, these next examples is what we did a few weeks ago, actually, by solving by factoring and using the zero product property to find the roots, equations, solutions, and x-intercepts. All mean the same thing. The solution for x are also called the roots of the equation. So in these examples, we solved by factoring. So looking at this first example, okay, we took out a GCF of 3x, undistributed the remaining polynomial, and then we set each factor equal to 0 to solve for the x-intercepts. So here the solutions are at x equals 0 and x equals -5. And this is an example when there are 2 solutions, just like above, because your only options are 2, none, or 1. This is an example of where we took out the GCF as well. X squared minus 6x equals 0. Took out a GCF of x, and then undistributed, and found our solutions at x equals 0 and x equals 6 by using the zero product property. I know I'm going kind of fast, but this is something that you're able to pause and play. So from here, we now saw that we had a trinomial where a equals 1. So we did the x factor. Remember, a times c goes up top and b goes on the bottom, and then you find numbers that multiply to 16 but add to 8. We came up with 4. Well, the thing is x plus 4 and x plus 4, they become identical factors. So you only have to solve 1 and set it equal to 0. So this is an example of when you have one real solution, which means that your parabola sits on the x-axis. The vertex does at -4. All right, so these are some other examples that we covered today. I'm just going to let you see those examples. D, E, and F, D and E, I should say, are examples when A is not equal to 1. So don't forget, when A is not equal to 1, you're multiplying A times C. So 5 times the -4 is the -20, goes up top. -8b goes on the bottom. And then you put the 5x and the 5x because it's your ax, and then you look to simplify vertically. We divided by 5 on the left side to get x and a -2. On the right side, 5 and 2 is simplified, so we just put that back into parentheses and put 5x plus 2. After that, we set x minus 2 equal to 0, and then we set 5x plus 2 equal to 0 and solved to get x equals 2 and x equals -2/5. So example E is the same thing, so I'm just going to let you look at that for a second and make your comparisons. All right, so example E, we did the same thing. We look for a GCF first. There isn't one, so 12 times -2 is a -24. B goes on the bottom. And then you get your factors and set them equal to 0. That's all review. The next one we said is we looked at F, and then we used dots instead of the square root method. And we made one positive and one negative, and we came up with 4x plus 5 and 4x minus 5, setting them equal to 0 to get solutions at -5/4. Sorry, -5/4 and x equals +5/4. All right, so that's what we did together. What I told you guys that I'm going to go ahead and create video notes on more about factored form and graphing from factored form. Okay, it's really the same as standard form, but less work.